Uh, Thank you, Dr. Suresh and Dr. Dev Pujari for the introduction of the webinar. This is the last of the series of the second season of webinar, and I hope that next year we don't have seasons of webinar, but we have physical meetings. And but this time we had a different topic of using different type of instruments in endoscope, and I'll be speaking on using lasers. Here, the talk is more on the first part is just showing an example, one or two examples of where laser is useful. But most of the talk is on what is laser and how to choose the right laser. Because in if you see, there are many types of laser available used by different kinds of department, and the neurosurgical laser actually is borrowed from the urology laser. So I'll speak on what is laser and how to choose the right laser for our use. And this is an example of a case of a suprasellar arachnoid cyst. You can see here this case was done without laser, where the floor of the roof of the arachnoid cyst was so thick and it was a little difficult to puncture and difficult to dilate also the opening because it's very thick. So this is what happens when we use the standard techniques. And this is another case of a suprasellar arachnoid cyst, very thick membrane, and I know that it's a struggle for perforating this. And you can use a monopolar, bipolar, then Caesar, but one has to use multiple passes of instruments to make a perforation in this kind of thick walls. And then dilating also with Fogarty is not easy. One has to use again scissors and coagulation, and takes longer time. Now this is a case which actually we used laser. This is another case of a suprasellar arachnoid cyst. So here again you can see that the arachnoid cyst bulging into the foramen of Monro, and here is laser. You can see here it's so fast. It just can coagulate precisely, and then in cuts and coagulates simultaneously, and it shrinks also the arachnoid cyst. So it makes things faster, and many times after doing the cystoventriculostomy, when one goes to make this the cystocysternostomy, where also the arachnoid is thick, laser helps, because using when you use a bipolar, it becomes still opaque, still thicker, and then using scissors become blind. Whereas laser, one can do it in a precise way, and then use that to widen the opening. Now, the decision is when you use the laser, whether it will puncture the vessels in front of it. So that is why one should know what is the working distance of the laser, the safety distance from the laser tip to the structure which will damage. Is it 1 millimeter, 2 millimeter, or 1 centimeter? So that is why it's important to understand the mechanism of laser, so that one can decide the safety margin of using laser, so that one does not inadvertently puncture the vessel which is in front of the working, near the working membrane. So this is the third case which you use laser, and then it becomes faster and more comfortable. So the advantage of laser is it's a precise cutting and ablation. It reduces the need to exchange multiple instruments. So it does the work faster and accurate. Hemostasis also can be done. And so overall, it decreases the overall working time and safety for the patient. So what is laser? Laser is light amplified by stimulated emission of radiation. Now what is stimulated? So it's a normal light, but what is stimulated emission? Normally, in an atom, the light is emitted when the electron jumps from the higher to a lower orbit. So when you stimulate with another photon, and then the emitted light is called stimulated emission, where when the electron jumps to the lower orbit, you have a light emitted. So this is called stimulated. So in a laser, one gives a stimulation so that you get a higher light strength at the end. And it's collimated. A normal ordinary light is not collimated, whereas laser all are in the same direction, whereas in a light it is all in diffuse direction. So we do not get very bright illumination, whereas in a laser all are collimated. And their coherence. Coherence means in a normal ordinary light, the phase are all of them are not in phase. Whereas in laser light, all of them are in phase. That is why it delivers higher energy at the end wherever it falls. It's like using a lens. So a laser is monochromatic. All of them are in the same wavelength. They're coherent. They're in the same phase, and they're collimated, like they are in the same direction. That is why at the end of the light, it is concentrated and gives energy. So as I told, whatever we use is depends on energy, whether it's gamma rays or TV or FM radio, all of them or X-rays, all are a range of energy. So light also is energy what we use. The wavelength of light, what we see, the visible wavelength is from 400 to 700 nanometer. And beyond that, below that, it's called ultraviolet light, and more than 700 nanometer is called infrared light. Now, the laser, what we use, it can use the normal light, ordinary light from 404, as well as it can use the ultraviolet range or the infrared. So the lasers operate in both the visible range wavelengths as well as the ultraviolet wavelength and infrared wavelength. Now the different kinds of laser like YAG laser or carbon dioxide laser or ruby laser, argon laser, it has different wavelengths. So like carbon dioxide laser has a wavelength of 10,000, whereas Nd:YAG has 1,000, and whereas when you use a thulium laser, it is 2 micron. So each laser has a different wavelength. It can be from ultraviolet range to an infrared range or to a normal visible range. So that there are different types of laser, what we know, depending on the not only the wavelength, but also whether it is produced in a gas medium or a liquid medium or a solid medium. So in a typical a laser, there is a power supply where it stimulates the lancing medium, which can be a gas, liquid, or solid, and whatever light comes out, it is collimated by a reflective mirror. So this is what you have different kind of laser. It can be a gas, solid, or liquid. Depending on that, these are all the lasers which are available in the market, like UV, carbon dioxide, yttrium. You have semiconductor diodes, or holmium and thulium. Now, holmium and thulium are the commonest popular laser which is used in urology. Now, what we have started using, taken from the urological principles to neurosurgery to use this too, because they're delivered with a fiber. Unlike earlier when we used to use a carbon dioxide or yttrium, they were not fiber based. So it was a little difficult to use. And the other thing what one has to look at using is the tissue penetration. If it penetrates more, then it can be more harmful. Whereas here you can see the thulium or the holmium laser has a penetration of 0.4 millimeter, 0.5 millimeter. So when one decides to use a laser, the penetration should be less, so the less damage. So which one to choose of all the available ones? It depends on the penetration. You can see here that the thulium laser, the holmium, they have points of 0.4, whereas carbon dioxide is 0.02. It's very less, so it takes very long time. That is why carbon dioxide, it came 20, 30 years ago. It went into disrepute because it was not, the penetration was less, it took very long time. Whereas Nd:YAG laser, the penetration is very high, 10 millimeter. It can cause more damage. And so that is, again, that's what, though it came to market 20 years ago, again, it was not used very frequently. It's not only the penetration into the tissue, but also the working distance. The tip of the laser delivery device, the fiber optic cable, to the distance of the tissue. Now, if this distance is too high, then it can be inadvertent damage to all the tissue surrounding. So then it's not a good laser. The distance, working distance will be less than 2 millimeter or 1 millimeter, so that one does not inadvertently damage any surrounding tissue while working in either endoscopically or doing an open surgery. So when the working distance is 2 millimeter, then the chances of damaging the surrounding tissue is very less. That is why whenever one selects a laser, the working distance should be very small. Now, what really matters, how does a laser decides the working distance and the penetration of the tissue? So the working distance and penetration depends on the absorption of the target tissue of the light and the working media, like whether we are doing an endoscopic surgery like in water or doing an open surgery or a dry field, then the working media becomes air. So the working distance changes depending on whether you're working in air or water. In a thulium laser, the working distance in water is 2 millimeter, which is very safe. Whereas when somebody is working in air, the working distance becomes more, 2 or 3 centimeters. Then one has to be very careful. So so when one using a laser, one has to be very careful whether one is using water or air as a media. And the second is the tissue. The higher the tissue absorption, the better. Because if the tissue doesn't absorb, then the light can pass on to damage the structures beyond. So any laser which has a very high absorption of the tissue, it will cause less of penetration and less of damage to the normal surrounding structures. So for precise incision reparation, one has to decide a laser wavelength which needs a stronger absorption in not only the tissue, which target tissue, but also absorption in the media, whether water or air. So when you do an endoscopic surgery with water, one has to choose something which has a very good water absorption so that the working distance can come down to 2 millimeters. If the water absorption is less, like if this YAG laser, KTP laser, then the working distance becomes high, which is probably not safe while doing surgery. So that is why thulium laser, which works at 2 micron wavelength, holmium laser is good for neurosurgery because both of them have a good absorption in water. Similarly, both of them at 2 micron have, like holmium and thulium, have a good, very high absorption of tissue. So that's why the penetration is minimum and the surrounding damage is less. So whenever one chooses a wavelength of a laser, it should have a high water absorption as well as a higher blood absorption or tissue absorption that causes less of damage. So in turn, when you have higher absorption into the tissue, then the surrounding structures do not get damaged. Only the tissue is damaged, so that it is safe. Like the tissues which are 1 millimeter beyond are safe. So that is how this goes over bipolar. When one uses a bipolar, then the thermal damage is more than 1 millimeter or 2 millimeters. So laser scores over bipolar in this if one understands the absorption power of the tissue. So because of this mechanism, laser has advantage in precise cutting and ablation over a monopolar or bipolar. And because it does both coagulation and cutting together, it reduces the need to exchange instrumentation. In turn, it achieves faster and accurate hemostasis and helps in decreasing the overall time of the surgery. In conclusion, thulium laser or holmium laser, both are good, but thulium is better because it is delivered with a fiber optic one. And it can be used in neurosurgery as I showed in the example. Thank you for your attention.